Hello, I welcome you all to this another interesting screencast, and the problem reads: if F1 is equal to 100 newtons, F2 is equal to 120 newtons, and F3 is equal to 80 newtons, determine the magnitude and coordinate direction angles of the resultant couple moment. In the second case, determine the required magnitude of F1, F2, and F3 so that the resultant couple moment is 550I minus 45J minus 20K. Alright, both these problems are coming from the Engineering Mechanics Statics textbook, 13th edition by R.C. Hibbeler. Right, so let's start working on the problem. First and foremost, let's draw the direction of the couple moment on each of these particular valves. Okay, so let's start with F1. Where is F1? Here it is. So F1, it is negative, using the right hand thumb rule, is negative in the y direction, right? Let's draw. So it is something like so. Okay, so this is F1 times the lever arm. So this is just a 0.2 times F1. Okay, and then F2 is positive. It's positive, as in the x-axis is positive. Okay, let's draw the arrow. So it's going like so. So what's the value? This is also F2 is 0.2. That's the lever arm times the force. So it's 0.2 F2. And then F3, it is negative, going down, right? Using the right hand thumb rule, it's going down. It's going down. So it's going down like so. All right. This is the direction of our couple moment, and this is also 0.2 F3. All right. And then F4, it is positive in the x direction. It is positive in the x direction. So it is going like so. All right. Okay. It's going like this. Okay, but when we look at this couple moment, due to this couple forces F4, it is in the xy plane. All right, it is in the xy plane, and since this is the free vector, we can move it anywhere, but we maintain the direction. All right, so look at this. It is where it's in the xy planes, therefore it means it's going to have a component in the x and in the y, right? So if we are to move it in the xy plane, it will look something like this. It's supposed to look the same. Okay, all right, it's the same thing. Okay, because this is just 3D. All right, so this is, so before we find what this is, when you look at this particular couple system, we have a force. The distance between the two forces is supposed to be perpendicular. So when you look at this, it's not perpendicular. So we need to find the perpendicular distance. So let's draw that distance. Let me use black. Distance along the y direction, right? Okay, no, not that. Okay, something like that. Okay, and that one like so. Great. So that is better. Let me just wrap this up to there. No, not up to there. Up to somewhere here. I'll need a protrusion. Okay, up to something like that. Great. Then I'll need to draw another line. They are like this. Great. So now we have this particular perpendicular distance. This is a distance that we want. Alright. So what is this distance? This distance is the angle is 30 degrees with the y-axis. You've seen this angle here. So this is going to be equal to the length over this particular distance there is our arm where the forces are connected is 0.3. Okay, so it is 0.3 cos what? Cos 30. Great. Therefore, this moment this moment is going to be equal to, which is in the xy plane, is equal to 0.3 f4 cos 30 when we multiply all of them. Okay, but since this is in the xy plane, we need the components, right? So let's get the component. So I'll have one component in the x-axis like so. I'll have one component in the x-axis like so. Then I'll have another component in the y-axis like so. Okay. Great. There we are. So let's write down these components. We need the angle. But when you look at this direction, look at this. One side is 0.2, the other side is 0.2. So this is a perfect what? Square. So if we are to go halfway the perfect square like so, one direction is 0.2, the other direction is 0.2. What do you think is the angle that cuts diagonally like this? This angle there is 45, right? And so is 45, right? Therefore, this is 45 degrees, right? And so is the other one. Okay, agree? Great. So therefore, this component is going to be equal to 0.3 f4 cos 30 cos 45. Okay, and this one is also 0.3 f4 cos 30 sine 45. We know cos 45 sine 45, they are the same, right? Cos 45 is equal to sine 45, right? Great. So once we have that, then we can start writing our equations very fast. Okay, because one part of the problem is solved. So case what? Case 4-95. Great. So what do we have? So let's say our resultant couple moment. I'll write it in terms of F is equal to, what is the component in the x-axis? We have two components, both positive. So we have 0.2 F2 plus 0.3 F4 cos 30 cos 45. Alright. Then in the y direction we have two, both negative. So we'll say minus 0.2 F1 plus, I've already put a minus there, 0.3 F4 cos 30. Okay, this one was sine, sorry. This one here, it is sine. Okay. This is sine 45. So cos 30, cos 45. Okay, I'll just collect it like so and just bring it here. Right. J. And then in the y, we have just one component, that's a minus 0.2 F3 K. So this is the expression, and we've already been given what F1 is. F1 is equal to 100 newtons. F2 is equal to 120 newtons. And F3 is equal to 80 newtons. F4 was already given in the problem itself, in the figure. It's just 150 newtons. Therefore, our resultant couple moment is just going to be equal to, maybe it's too close. Our resultant couple moment is equal to, grab your calculator, start plugging in these values. So we have 0.2 by F2, that's by 120, plus 0.3 by F4, 150, cos 30, sine 45. So this gives us a positive 51.56i. Then minus 0.2 by F1 plus 0.3 by 150 cos 30 cos 45. So this gives us a 47.56. All right. And then we have, that is J. Okay. In the J direction. Okay. Then minus 0.2 by F3. And F3 is 80, and this gives us a 16K. Alright, this Newton meters. Let me just check this again. 0.2 by 100 plus 0.3 by 150 cos 30 sine 45, 47. 0.2 by 120 plus 0.3 by 150 cos 30 sine 45, 51.56. Okay, great. So let's find the magnitude of this quickly. Let's find the magnitude using Pythagoras theorem. So we have 51.56 squared plus 47.56 squared plus 16 squared. Square root of that, we are going to find a 71.95 Newton meters. Alright, so let's find the unit vector along that direction. Let's find the unit vector. The unit vector is going to be equal to MRC divided by the magnitude. This is equal to 51.56 I divided by 71.95 minus 47.56 J divided by 71.95 minus 16K divided by 71.95. Therefore, cos alpha being the angle between the positive x-axis and the moment vector, is going to be equal to 51.56 divided by 71.95. Therefore, alpha is going to be equal to 51.56 divided by 71.95. Cos inverse of that, it gives us a 44.22 degrees. Then we have cos beta. Cos beta is equal to minus 47.56 divided by 71.95. Beta therefore is just going to be equal to minus 47.56 divided by 71.95. So this gives us 131.38 degrees. Then we have cos gamma is equal to minus 16 divided by 71.95. Gamma therefore is equal to minus 16 divided by 71.95. This gives us 102.85 degrees. Alright, so let's go to the second case, which is case 4-96. So in this particular problem, they've given us already the resultant couple moment, and they're asking us to find F1, F2, and F3. Okay, so we have, let me just write down here, we have this expression here, which I will not get. This expression, you've seen this expression because of lack of space, but maybe let me get it. I didn't want to bring it here because of space, but maybe let me bring it. So there we go. We have this equation here. Maybe let me stretch it a little bit out. All right. I stretch it up to somewhere there. I just put a boundary somewhere here like this. Great. Okay, there we go. So we have this moment vector there. We have this component there, the minus there, and then this other part here. Okay, great. Then we have this other equation where they've told us already that our resultant that is given is equal to, let me just write it away. Our resultant that is given is 50i minus 45j minus 20k. So what we need to do now is to equate these two equations. Okay, these two expressions rather. Okay, so it means this component here will be equated to this component here will be equated to this, and this component will be equated to that. Okay, so let's do that. So we are going to have three equations since we have three unknowns. So we have 0.2f2 plus, can I just not copy this again? I think I can copy this so that I don't spend so much time writing this stuff that I already have. Let me copy that. This, I bring it here like so. Okay. Alright, let me just rub a little bit of this stuff here. So I'm equating these two. If I equate these two, and I still need some space, to there, something like so. Right, so let me get this, I bring it here. So we have one equation, which is this one here. Alright, so this is equal to 50. Then I have another equation, which is 0.2 f1 plus 0.3 f4 cos 30 cos 45. This is equal to so it's both are minuses, so the minuses will cancel, so this can just be like this. And then we have the last one but not the least, it's a 0.2 f3. The minuses again will cancel, equal to 20. Right, so from these equations we can find directly what f3 is from this the last equation, this one. Okay, f3 is going to be equal to, f3 will be equal to, that's 20 divided by 0.2 is 100. This is 100 newtons. If we found f3, then we can plug f3 into okay, this is just alone. Okay, then we have already f4 here. If you remember, f4 is already known. f4 is equal to 150 newtons. So just plug this one here so that we find what f2 is, and we also plug it there. Okay, so we find what f1 is. So f2 is just going to be equal to 50 minus 0.3 by 150 cos 30 cos 40 cos sine 45 divided by 0.2. So it is 112.22 newtons. And then f1 finally, that's 45 minus 0.3 by 150 cos 30 cos 45, then divided by 0.2, we get 87.22. Let me just repeat it again. 45 minus 0.3 by 115 cos 30 cos 45 divided by 0.2, 87.22. Great. So I think we are done. Let me just outline the solutions. We found the couple moment itself in case 1, and we also found its magnitude using the Pythagoras theorem. And the question went further to ask us to find the directional angles, which we found. Okay. Then in case number 2, they are asking us to find the couple forces given the resultant moment. And we found the values of F1, F2, and F3. Okay. So this is about it. This is really about it, and I hope the video was helpful. And if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.